All right, physics studying because I have an exam February 6th. This February 2nd. Just going through some of the PowerPoints. Physics 114, Physics 1. Define allometric scaling, recognize power laws, and describe conceptually what they express by mathematically. Combine scaling relationships to create new scaling relationships. No, important. So check mark. Check mark means important information on the exams. Okay. Isometric scaling. So ISO means same. Proportional scaling, shape does not change with size. All linear dimensions increase at the same rate. All right. So is that isometric scaling or proportional scaling? Or those? Oh, so I'm assuming isometric and proportional scaling mean the same thing. And allometric scaling means different. So shape changes with size, i.e., the relative proportions changes. So like when a child is born, their head is unproportional is large in proportion to their body, but as they grow, it changes. So like different parts of their body grow at different rates. So that'll be allometric scaling, and isometric scaling would be growing at the same rate. White monster, bro. Uh, let's write down some terms here. Isometric slash per proportional proportional scaling. Everything, I'll just say for the definition, everything grows at the same rate. Everything grows at same rate. And that is isometric slash proportional scaling. Allometric scaling is different. Shape changes with size, the relative proportions. Um, not everything grows at the same rate. That's what I'll say. Not everything grows at same rate. It's probably the best definition of it. I need to sharpen my pencil. I'll say example is head is not equal to torso growth as we age in proportion. Head growth is not proportional to torso growth. Proportional to torso growth as we age because babies are born with big heads. Because babies are born with big heads in proportion to their bodies. That's another thing that you'll learn in paramedic training is just pediatric patients have what is it? It's like bigger airways in proportion to the rest of their bodies, or in proportion to adults relative to their body. You sharpen my pencil. I had a pencil sharpener right here. There we go. Sharpen my pencil so I can write faster. Just can't write as fast with a dull pencil. All right, power law functions. Scaling relationships are expressed using power law functions, meaning that a and b are constants. So y equals ax to the b. So y would be the body part being measured in relationship to organism size. A and b's are the constant. X is the measure of how big the organism is, mass, height, weight. So okay. Power law functions. Y equals a x to the b. So we'll say y thing being measured. And then x is mass slash height. A and b equals constants. All right. Positive is allometry. The exponent b determines the type of scaling relationship. So forearm limbs versus body length. If b is greater than 1, then as x increases, y becomes relatively larger. Y increases at a faster rate than like x. So this is body length as forearm length. So it looks like b in this situation is 1.28. So that means that y increases at a faster rate than this. So this is implying that as body length gets bigger, forearm length increases faster than body length proportionally. Okay. And then A here is just the average body length when the forearm length is 0, when they don't have legs. So I guess this would be known as positive if what it's above 1, or what is negative. So negative, the exponent b determines the type of scaling. So if b is less than 1 but it's positive, then as x increases, y becomes relatively smaller. Y increases as a smaller length at a slower rate. So as body length increases, or head length, it's still increasing as body length increases, but it's increasing at a slower rate than body length. So this will be known as negative allometry, or however you say it. Allometry, is that how you say it? So yeah, I think that's pretty self-explanatory. So positive allometry is B is being greater than 1. And negative allometry is B is less than 1, but it's still positive. So you could say on the other end of it that it is greater than or equal to 0. So 0 is greater than or equal to B, but less than 1. Cool. And that's negative allometry. And then isometry is B equals 1. And this will just be a direct linear line. This is going back to like high school algebra, bro. Pre-calc. It's been like 4 years. That's crazy, man. The exponent b determines if b equals 1, then the relative size of y stays the exact same. Yep. So I'll say isometry is b equals 1, aka just a linear line. Combined power laws, problem solving strategy. Identify the relationship you want. Example, form length requires notes. Oh, yeah. So this is just saying for this last example where we said forehead length was equal to body length at a 1.28 coefficient, which is right here. And then also this one is body length would be equal to head length at a 0.72 coefficient, right? Take the quantity you want and the company. And it looks like this way. If you're saying head length is equal to body length at 0.202, you can just flip it and say body length is equal to head length, and you do the inverse of 1 divided by 0.72. And then, so, all right. So if head length to the 1 divided by 2 is equal to body length, then that means, yeah. So conclusion. What in the world? Oh, because at the top it's saying if what is it, forehead length is equal to A of head length to the B. And we've already discovered that down here that forehead length is equal to this. That does not really make sense, man. I'm gonna be honest. B equals Are they just saying for that one, they're just putting 1.28 over that instead of 1? I think that would make sense. Because if you have like a number, say, raised to 1 divided by 0.72, and then you multiplied that to the 0.128 power, would that also just be equal to, we're seeing, I'm checking my, yeah, it's the exact same thing as that. So they're saying if that's equal to B, then in that scenario, B is equal to 1.78. Okay, cool. So they're just mixing numbers around. All right. Maybe that'll be an exam question. I'll have to figure out really fast. I guess that's good or no. Scaling relations to memorize. Most scaling relationships will be given to you. You don't need to memorize them. There are 3 scaling relationships you should memorize for isometric growth. All dimensions grow by the same factor. How surface area scales with size, volume, and mass. So there will be formulas for that, I'm assuming. We use units of length, feet, meters. So surface area, um, just looking at some of my recent ChatGPT searches, people are gonna catch me lacking, bro. Grind station vibes, content strategy, custom water bottles, AI image, Xbox controllers, antibiotics. Nah, can't catch me lacking, bro. Just been asking ChatGPT medical questions and business stuff. LOL. We can ask ChatGPT this question. So surface area, right? Surface area is just it's not volume, so it's just calculating the area of something. So like the surface area of this table would just be like length times height, right? Not even length times height, it would be like width times length. So which would be squared. Volume would be cubed, right? So I'm thinking the answer for this is B. We can ask ChatGPT though. Should be B. Yep, let's go. B. Did a whole lot of yapping and not tell me anything. Cool. The answer is B. I was right on that one. Yeah. Oh, okay, cool. So it looks like it filled it out anyway. Hope I don't get kicked out of school for showing the lecture PowerPoints, but I don't really care. This is going to get clipped up and made into edits. Can I get kicked out of school for like teaching people physics for a test I'm trying to study for? You tell me. I mean, the world is extremely corrupt anyway. And they just send men to die in Ukraine in ditches and to launder money because they think it's funny. So, I mean, I don't know. Um, what is this? We will use units of length to measure the linear dimensions when we talk about the size. Blah, blah. Which of the following relates the volume, right? So volume is length times width times height. So it should be size cubed or typically meters cubed. Yep. Let's go. Mass. When we talk about the mass, we are usually referring to, yep. So usually mass is just like in one unit. You're not multiplying anything together to get mass. So I'm gonna either say it's A or because typically for mass, like mass is how much something weighs, right? And I feel like weight is dependent upon density. It's not really necessarily size. So I'll go with D. Is D right? No. Mass is a unit of cubed. So mass is density times volume, right? So I guess if volume is size cubed, right? And density, let's ask ChatGPT. Why is mass? All right. So mass is equal to density times volume. So let me ask ChatGPT this. All right. So if mass is equal to density multiplied by volume, I get that volume is cubed, and you're multiplying it by density. But does density have no units? Right? Is that the only reason mass is cubed because density has no units and nothing cancels out? Density absolutely has units. So density is mass divided by volume. What the? That doesn't make sense. What are you talking about? Well, you just said density is mass divided by volume. So if you're multiplying mass divided by volume to get mass, which you're saying is units cubed, then that doesn't make sense because you're multiplying volume by something that you're dividing volume by. So wouldn't that just cancel out the units? I'm just not quite getting this. I talk to ChatGPT all the time. Like this is weird. Like I know we talk about AI and like people like having like AI relationships. I talk to ChatGPT all the time because ChatGPT is extremely judgmental and it'll tell you exactly what you need to do all the time. You can talk to ChatGPT about your personal problems, about your friendships, and ChatGPT would just break it down in like a really non-judgmental way and will like actually make you feel better about yourself. And also you understand it's a chat bot, like it's not real, but you're just kind of just like thinking like, you know what, like is there someone else I can talk to about this? Most of the time, like most of us, like we don't have like a friend or someone we can call up instantly to talk about our problems with, or we don't want other people to know about our problems. So it's a lot better to just ask the chat bot. All right, so mass equals density times volume, which is equal to mass times volume multiplied by volume. Oh, so that would just cancel out to massive. That would just equal mass. Okay. Mass scales as size cubed, not because of unit cancellation, but because volume changes with size while density stays constant. Volume changes with size while density stays constant. Okay. I don't quite get it. I'm going to be honest, but just for this sake, it is what it is. So mass is equal to density times volume, and we know volume is unit cubed. And apparently, okay, whatever. We'll just write it down. I don't quite understand it, but it is what it is. That's how the world works. Sometimes you don't quite understand how things work, but you have a job, you have to take an exam on things, and you just have to know the right thing to say. That's why you study. Note about size and suicidal ideation units. We use units of length to measure the linear dimensions of objects. Yeah, so when we talk about the size, we're usually referring to linear dimensions. All right, so 1 meter is equal to 1.1 yard, 3.3 feet. 1 meter of area equals 10.7 squares. I don't know if we quite need to know this. So it might be good to write down. I'll ask them about it. I'll make a note of it. Or I'll just make a Google Doc here. Cool. Typical question. A dog's mass doubles over a period of 18 months. Assuming the dog grows isometrically, what is the change in the dog's surface area to volume ratio? So we just said surface area grows at a rate of size squared, and volume grows at a rate of size cubed. So, assuming the dog grows isometrically, meaning everything grows the same, what is the change in the dog's? The ratio should be um, at a rate of 2/3, right? So, if surface area doubles, then volume should triple, right? That's how it should work. So, which of the following correctly represents how surface area to volume ratio scales with size W? So, size, yeah, so surface area is on top. We know the surface area is a unit of squared and volume is a unit of cubed. It should just be size to the 2/3. I wouldn't think it would be negative. So, we can even do it. So, we could say, um, if surface area is, say, 20, yeah, it should be that. To the negative one, oh yeah, because it would just be yeah. So for example, that's exactly what you're doing. You're taking the exact same number to the second power and you're dividing it to the third power. So instead of it being something to the 2/3 power, it would just be to the -1. Because you could say, for example, you could do, say, 10 squared divided by 10 cubed, and that would be 1/10. And would that be equal to 10 to the 2/3? No, it's not. But 10 to the -1 should give you, yeah, 1/10. Yeah, so this is wow. This is like basic algebra that I knew very well when I was like 16. I did the SAT, but I'm 20 now, so forgotten a lot of this stuff. But yeah, so you can just say this is a good thing to write down. So if you can say if surface area divided by volume uh, equals size to the -1, which is basically just shown by, we'll say L squared, which I'm assuming in this area just means by length, which equals L to the -1. Basic algebra. But it's good. It's good. That's why you study. This is why you practice test, because university is extremely difficult unless you work through practice problems and you review the material and you mess things up and you learn from your mistakes. That's the only way that you can ensure when you take the exams or when you take the MCAT or when you're actually doing your paramedic calls and you can't screw up. This is the only way that can ensure that you don't mess up on the real life attempt, because you spent so many hours training and spent so many hours messing up and fixing your mistakes. It's the only way you're ever going to be able to not make mistakes. So it's very important that you fail and you learn from it. You got to be willing to fail and make mistakes first. The surface area to volume ratio, yep, is size to the 1/3. Which of the following statements is correct? As an organism grows, its surface area decreases. That is not true. As an organism grows, its surface area increases by a faster rate than its volume. That is also not true. As an organism grows, its surface area increases by a smaller factor than its volume. That one would be correct, because remember, they're both increasing. It's just surface area is increasing by a smaller factor than the volume. Yeah, so that's right. That would be D or C, right? So C is the correct answer. Typical test question. Which of the following correctly represents how the surface area to volume ratio scales with mass? So we already said that mass is equal to um, what? Something cubed. So surface area to volume is equal to size to the -1. So if surface area divided by volume is equal to size to the -1, and mass is equal to size to the third power, so this would just be, all right. So how could we rewrite this? Because apparently mass would just be to the third power. It would be L cubed of what we said earlier. And surface area to volume is L um, to the negative. So it wouldn't be to the -2/3, right? Because you're not. Hmm. Well, no, I think it would be to the 2/3. It would just be to the positive 2/3. Because if you have a surface area, say, of 2, you know the volume is just going to be 3. So your mass would just be 2/3 of that, right? So it would be C. No, it's B. So I don't quite understand this. All right, so yeah, mass is L3, and then okay, so L is equal to mass of 1/3, which would make sense. So if surface area divided by volume is equal to L to the 1/3. Oh yeah. So you're really breaking it down. So if you know that mass is equal to length cubed, you know that length in of itself is equal to mass to the 1/3. So if we knew from the previous question that surface area divided by volume is equal to length to the -1, so that means that mass to the 1/3 is also equal to that to the -1. And then yeah, it's not complicated. It's just SAT math that I knew how to do very competently when I was 16 years old because I did nothing but practice it. But I don't quite understand it. So it makes sense now that you've seen it, but you really got to break down what you have and you got to do it. Cool. That's another one to write down. Surface area divided by volume is equal to mass to the -1/3. And we know that because what did we say? We said that mass is equal to length cubed. So we know that length in and of itself is equal to mass to the 1/3. So that means that surface area wait a second. So that means that if length is equal to mass to the 1/3 and length to the -1 is equal to surface area divided by volume, we know that mass divided by 1/3 to the -1 is also equal to surface area divided by volume. And then mass to the 1/3 to the -1. All right, so let me write this down. So surface area divided by volume is equal to mass to the 1/3 multiplied by a -1 exponent. So, for example, if you have 10 multiplied to the the 1/3 power multiplied to the -1, you get 0.46. So I wonder, is that the exact same thing as 10 multiplied to the -1/3? And it is. So surface area divided by volume is equal to mass to the -1/3. And there you see it. There you know it. Cool. So, typical test question. A dog's mass doubles over a period of 18 months. Assuming the dog grows isometrically, what is the change in the dog's surface area to volume ratio? I didn't look at it. I didn't look at the answer, so I don't know, but I saw the answer was there. So, a dog's mass doubles over a period of 18 months. Assuming the dog grows isometrically, what is the change in the dog's surface area to volume ratio? So, we already said that the surface area to volume ratio is equal to mass to the -1/3. So, What is the change in the dog's surface area to mass ratio? You said it would grow asymmetrically, so wouldn't it just be the exact same thing? So if a dog's mass doubles, the dog's mass doubles, then the surface area and the volume. All right. So, all right, let's break the math down with this. All right. So, for example, if we know that surface area is equal to volume, surface area divided by volume is equal to mass to the negative one third. So, if the mass doubles, right? The mass doubles, then that means you just multiply mass by 2, and then surface area divided by volume should 2. So the ratio, wouldn't it just stay the exact fucking same, you would think? All right, yeah, so this is what it's saying. All right. So it's saying this is the mass of the first dog. And this is the mass of the same dog, but it grows. So it's twice that multiplied to the one third. And then it's just 2 to the negative one third power. I guess I didn't quite understand the question. And my dad's talking about some basketball game downstairs. I'm trying to study. And it's very annoying. Yeah, so you do 2 to the negative one third, and that'll be 0.79. So what is the change in the dog? So 79% of what it used to be, or 29. Yeah, I mean, I guess 79% of what it used to be, or 21% reduction, but it got bigger. Um, so a dog's mass doubles. What is the change in the dog's surface area to volume ratio? Right? Oh, because yeah, the volume is growing at a rate of cubed, and the surface area is growing at a rate of squared, right? So obviously, like the volume is getting bigger, but the surface area is getting bigger, but also at a slower rate. So the ratio is changing. So you're literally just plugging 2 to the negative one third into a calculator, and you're saying the ratio is 0.79. So okay, that's a who whatever, dude. Who cares how much the ratio's changed? Literally, I get it. Why does this matter? That's a great question. Why the hell does this matter? The number of cells inside an organism, its volume. So if an organism's size doubles, the amount of food and air it needs goes up by a factor of 8. It goes up by a factor of 8. Yeah, because if it's cubed, because it's something. Yeah, if it was squared and it doubled, it would go by 4. Okay, but food, air, and gases are exchange areas. Go up. Oh, interesting. Some some structures do not scale isometrically as the organism grows. Worms have a simple tube. Humans have intestinal surface areas that is approximately the size of a football field. All right, cool. Well, alrighty, friends. That was it for my first physics lecture. We have about like four more to go because I'm missing one PowerPoint here.